Okay, this animation is referred to here as miln3.10,000.gif. The reason it's called 10,000, I believe, is because I originally constructed it with 10,000 dots. And the reason for the 3 is it's because all of the dots had a rapidity between 0 and 3 going off in random directions. Now this code is basically sort of a rudimentary model of the universe. What it would appear to look like if you could take a cross-sectional area of the universe and observe it from outside, in a way, just the cross-section of it, and you didn't have to wait for the light to reach your eye because the that particular part of it is not implemented. And here's the basic code, and it's been modified a little bit since I made that particular thing. For one thing, I've added these circles. Everything between, let's see, circles, everything involving those circles was added later. And basically I added 2 circles to the diagram that were in rapidity space. They appear to be perfectly circular, but in regular space, one of them appears to be circular and the other one appears to be more or less elliptical. And you might be also interested to see that here this dot, this central dot, is at the center of the circle. Over here, the dot is kind of way over at the edge. In any case, I don't want to focus on those circles right now because it's kind of hard to explain why I was putting them in there. So what I'm going to do is I'm going to change this dots from 20,000 to just like 1,000, just more for my benefit than yours at this point. I want to play around with this code because what I'm going to do right now, this basically is representing a single explosion that occurs, and it goes out for some time, but what I want to do is add a secondary explosion, and with 20,000 dots, the rendering time for the thing is about 10 or 15 minutes, so I'm going to cut that down to about 1,000 dots, and maybe even less, to cut down the rendering time. First thing I'm going to do is just get rid of all of this code that involves the circles, so I'm going to comment that out with a parentheses asterisk, and let's see, I guess that's, no, maybe I need to do another parentheses asterisk. Let's try one right there, and one right there. Get rid of that line too. So, and then, okay, here's the graph with just 1,000 dots, and we got rid of those red circles. And anyway, what I want to do to this is put in a secondary explosion somewhere maybe over here in this region. And in order to do that, I'm going to create an X explosion, Y explosion, and T explosion, and set those equal to, say, 1, 1, 1. Or, actually, since I said I wanted over on the left, I'll make it -1, and I wanted it central on the Y. And it'll be about 1 unit of time after the original explosion. These are just kind of arbitrary numbers. And here's where I want to change things a little bit. I have this append to p-table, and this puts in each individual dot going at a velocity vx and vy at time t, and I want to have an additional append to here, but it's going to be an if t is greater than time of the explosion, then we will append to our p table. Then we will append to our p table another position. Actually, this position thing just takes, all it does is append to the table vx times t, comma, vy times t, and the only thing I want to change here is we're going to make this t be, I believe, yes, we want it to be, instead of t, we want t minus te, so that it will be t minus te. And then I want to add to these the offset of the x position of the explosion and the y position of the explosion. And what else did I want to do? We need to change the plot range so that x goes from -2 and y, that won't be square, but we'll see what that looks like. Crossing my fingers and hitting the enter button. And I'm finding that this is almost, but not quite, exactly what I wanted. So right around here, bam, secondary explosion. Now, essentially, I kind of cheated and used the exact same explosion, the exact same random numbers to produce this. So, but anyway, the idea of this, I wasn't thinking about it, the fact that these two parts of the explosion would align. But this is the essential idea that I wanted to get across, was the possibility of a Big Bang and then a secondary Big Bang that happened later. So one thing I'm going to change is I want it to happen a little bit closer to the center, so I'm going to change this to a -0.5 for the x. Let's see how that one looks. And bring it down here. It'll take a little bit. And here it goes. Okay, so that is a secondary explosion that occurs a little bit closer to the center. But anyway, the idea behind this is that we have essentially a two-bang system, and this is what I think might be a plausible explanation for what we see. The Hubble's law applies to everything in this region here, everything coming from that secondary explosion, which we can presume happened around 13.7 billion years ago. However, we can also see particles from that outer system, which happened longer ago and happened further away. So now I'm going to do something that will mean I am going to wait a very long time, and you will not have to wait so long, because I'm just going to pause the recording while this thing renders this, and after it's done we might be able to see a much more closely packed environment with 20,000 dots rendered instead of 1,000. Okay, I think it took about an hour, and all we have really is a new explosion with more dots. So here's how the explosion looks, and then we get a secondary explosion right there, and you can see it's coming out. And basically, it'd be kind of nice to see both of them together. But this is basically the concept, is that we have an inner part of the sphere coming out that is definitely finite, and it's 27 billion light years across, and then somewhere out here, which we would observe as perhaps a additional activity somewhere around 7 billion light years away, would be the front wave of this phenomenon, and then it would basically just continue like that. So I will let's see how the GIF file came out, and it looks pretty neat. Could be nice if it was I guess it would be better if it showed more, so that this thing, the outer part, remains a sphere as the inner part comes out. But you can kind of see in here, in the center, the dots are intermingling from the or dots in here are intermingling from the first explosion and the second explosion. So that's kind of but you barely see any difference between the two. It needs to go on for another few frames, really, to see it. But that's going to take another hour and a half or 2 hours of processing. Of course, one would need to kind of come up with an explanation for why there would be a secondary explosion, which I really have only the wildest speculation about. But from what I've understood of the data, there do seem to be pretty strong correlation between velocity and distance within the nearest billion light years or so, and then outside of the nearest billion light years there is a much worse correlation between distance and velocity. And I think that's I think that we're looking at something like this with a primary and secondary explosion.